So good day everyone. We'll be talking about mainly about the gyro compass and with its subtopics gyro error, relative bearing, transit bearing, and bearing from a known position. So our course outcome is to develop understanding about this specified topic and to effectively apply correct calculation discussed in the presentation with regards to the topic. While our learning outcome is on the completion of this presentation, we hope that you will be able to demonstrate correct calculation with regards to the topic and establish good understanding of the topic. So, the importance of this is that there are some drawbacks of such of the gyro compass, which is a navigational instrument on board ship. And with this presentation, we will be able to solve such drawbacks present in the use of gyro compass, which is very important in navigation. So, without further ado, let me argue with you that it is properly believed that the gyro compass indicates true north, but this is not necessarily the case. So, the gyro compass is subject to three errors. It's the course, speed, and latitude error, and this is kept by a minimum input and through corrections. So not totally that the result of this correction is accurate, but we minimize the error that are present in the gyro compass. Then this is rarely more than 1 or 2 degrees for a correctly maintained gyro. So um, ang error sa gyro is naara sa 1 or 2, and it's rare case nga mulapas na siya more than na ana siya. So rare kay na siya nga mahitabo. Then to avoid in that part, if rare na siya if nga correctly maintained inyong gyro, pero if ang inyong gyro is kanang wala gina maintain, wala gina check, so ang possibility nga dako ang error sa inyong gyro kay modako pud kay di wala man ninyo giampingan inyong instrument. So maintaining correctly maintaining the gyro is very important on board ship. So to avoid confusion with magnetic errors, gyro error is named high H or low L. So ang magnetic error, as we all know, ang magnetic error is ang deviation of variation. So is applicable to variation and deviation, while ang sa ato ang gyro compass gilahi siya kay pwede maglibog. Ang gyro error niya is named H for high and L for low. So the next thing is that gyro error is named high when the gyro course or bearing is higher than the true course. So or the bearing. So if ang gyro course niya is greater than the true course or the bearing, so mas dako ang gyro course kaysa atong true course, ang gi-subject na siya as high gyro error. And if this happens, the high error must be subtracted from the gyro reading to obtain the true reading. So if high error ka, dapat mo i-minus na ang gatong high error niya, ang value sa high error dapat i-minus nimo sa ato ang gyro reading kay pa makuha nato ato ang true reading. So the opposite applies to low error. So if low error siya, i-plus nimo siya kay pa makuha nimo ang true reading sa inyong bearing or course. An example is a gyro error is known to be 2 degree high. So 2 degree high. The true course to be steered is 0.76 degree. What is the gyro course? So gyro error 2 degree high. So high siya. So dapat na so high siya. Then the true course to be steered is 0.76 degree. So ang atong gipangitaan ni is ang gyro course, di ba? So gyro course, then state na og na if high course nimo, high error, error isubtract nimo sa inyuhang gyro course or gyro reading para makuha nimo ang true reading. Pero ang sa atong example, it states it questions what is the gyro course. So baliktad na to. So kay gisubtract man to nato, gisubtract na to ang high error sa ato ang gyro reading para makuha natong true reading. So diri nga example, ang high error nato of 2 degree i-plus nato sa ato ang true course para makuha nato ang gyro reading niya or gyro course. So true course 0.76 degree, gyro error 2 degree high, i-plus nato ang gyro course nato is 0.78 degree. So the next problem, a bearing taken with the same gyro gives 246 degree. Then what is the true bearing? So he's asking, a bearing taken with the same gyro gives 246 degree gyro bearing is, yeah. So ang gihatag niya is ang gyro bearing of 246 degree. So he's asking about what is the true bearing. So we have 2 degree high gina. Then he's asking about the true bearing. So what I have said gina nga, if high degree, high error I mean, if high error is subtract na to basta ang present niya is ang gyro course. Kung gipangita na to is ang true course gipangita na to di ang gyro course present sa problem. So ang katong high error dapat nato siyang subtract para makuha natong true course. Pero kung ang present sa problem is ang true course diyan kuha natong gyro course, i-add nato para makuha tong gyro course. So vice versa so dapat natong subton ang question, subton nato ang problem kay makalibog siya sa so dapat subton nato diyan. Dapat hinumduman nato ang basic rule niya. So in the example, so ang gyro bearing niya is 246 degree, gyro error is 2 degree high. So i-subtract na to as what the rule says. So ang true bearing niya is 244 degree. So an ato na to siya. So the next thing that we'll tackle about is the relative bearing, which will be reported by my other members. So thank you. And thank you for listening to my discussion about the gyro compass with the subtopic of gyro error.
Relative bearings. When bearings are taken using a pylorus or by radar with an unstable display, ship's head up, the bearing taken will be measured relative to the ship head rather than north. So mas labaw ginang north. Such relative bearing must be applied to the true ship's head to arrive at true bearing for plotting on the chart. This will entail changing the compass course to true and then adding the relative bearing if in 360 notation. Relative bearings refers to the angle between the craft's forward direction and the location of another object. For example, an object's relative bearing of 0 degrees will be dead ahead, an object relative bearing 180 degrees will be behind. Bearing can be measured degrees or miles. Using 360 notation is now normal practice, but if the relative's bearing is given number of degrees, green starboard or the right side is starboard, then it is also added. If the relative bearing is a given number of degrees, so kung ang given kay numbers kay degrees red port or right side, then it's subtracted. In the example, the relative bearing would have been red 86. To subtract this from the true course, it would have been necessary to first add 360. The answer is against 352. So to forget the correct answer, So 86 minus 90, then add 360 to get the correct answer, 352 degrees true.
Example for relative bearing working. A vessel is steering 073 or 73 degrees, and then the magnetic compass is the 69 degrees. All you have to do is to deduct it, and then same as usual, compass best, error west, compass least, error east. And then the result would be the deviation is the 4 degrees west. And then in order for you to get the variation is you need to deduct the magnetic compass and the true bearing, the 79 degrees and the 69 degrees. The result would be the 9 degrees, and then same as usual, compass best, error west, compass least, error east. So the result would be 9 degrees east. The relative bearing of Edward Island Light is 274 degrees. Then let's find out what is the true bearing of Edward Island Light. So the relative bearing of Edward Island Light is the 274 relative. And then let's find out the true bearing. All you have to do is to add the relative bearing of Edward Island Light and the true course of the vessel, which is equal to 352 degrees true course. So that is the true course of Edward Island Light.
Hi, I'm Cadet Paborada, Crescente. I will tackle today the transit bearing. When two well-charted objects are in transit, a compass bearing is taken. Kung gano kanang kung duha ka buok object nga kuan kanang mulabay kay dira makuha ang kuan compass bearing kuho. The true bearing is taken from the chart using parallel rulers. Ang true bearing kay kuan kanang makuha siya pinaagi sa kuan parallel rulers, gamitan nimo og kuan mga gamit para makuha nimo ang kuan niya true bearing niya. Comparison of the compass bearing and the true bearing gives the compass error. Makuha ang compass error niya. A transit bearing when two or more objects lie on the same line as in. If the division is required, it is calculated by applying the charted variation to the compass error. Kung ang division kay nanginahanglan og kuan, kung gikinahanglan ang division, kinahanglang makuha siya pinaagi sa pag-apply og charted variation to the compass error. Sa pagkuha sa kuan compass error, kinahanglan gamit ka og azimuth circle sa imong compass. Ang pinakalisod ani nga pagkuha sa compass error kay magamit ka og piloros para sa relative bearing, then usapan nimo i-convert para makuha nimo og compass bearing. Thank you.
In this case, a bearing has been taken of leading lights 0-45 degrees. So true bearing, compass error, variation, and therefore the deviation. So let's find out. The true bearing is the 0-45 degrees and the compass bearing is the 45 degrees. All you have to do is to deduct it, and then the sign of the error would be compass best, error west, compass least, error east. And then the compass error is 3 because of 48 minus 45, 3 degrees west, and then the variation is 11 degrees east, and then all you have to do is to deduct, and then same as it goes, equals 8 degrees east. In the second method, you require to know your exact position. This can be obtained by A. Correct GPS. B. Ranges from radar. C. Ranges from vertical sextant angles. The object should be on the chart and will distance from the vessel. By bearing from a known position. When the vessel's position is accurately fixed, a compass bearing may be taken of a well-charted and distant object. say a tower as figure 2.8 shown below, the true bearing can again be taken from the chart using parallel rulers, calculations made above. Any small changes in the vessel's position while swinging will have a negligible effect on the true bearing if the chosen object is sufficiently distant. Example, the true bearing of a light is 50 degrees and then the compass bearing is 33 degrees. Then all you have to do is to deduct it. The compass error will be 17 degrees east, and then the variation is 11 degrees east from the bearing taken from lights 045, and then the bearing of the 045, the compass error, and then the variation is 11 degrees east. And then all you have to do is to deduct the compass error 17 degrees east and the variation 11 degrees east, since it has a similar or the same in east. Then all you have to do is to copy the deviation would be the 6 degrees east. That's all.